we left off where we finished. We created our own scatter plot. We found the slope and y-intercept. We drew an equation of the line, right? Linear equation, linear model, based on the scatter plot, trend line, all that jazz, right? So that was pretty easy for the first two examples, okay? We interpreted what does the y-intercept mean, what does the slope mean for each of these scenarios. And then we quickly, very quickly, used the linear regression app on your iPad. And I had you guys enter the x's and y's as ordered pairs. And we found our linear model, right? The linear equation was given to us. They gave us the slope. They gave us the y-intercept. The correlation coefficient, that's, remember, the closer it is to 1 or -1, you're going to have a strong positive or strong negative connection, meaning they actually do have something to do with each other. We interpreted the slope, right? $4,900 extra per extra foot length of the boat. And then we didn't do part D. So here we go. It says approximate the cost of a sailboat that is 20 feet long. So we're going to use our linear equation here, because what does y represent? Cost. What does x represent? The length. So how am I going to use this equation to find out the approximate cost of a 20-foot sailboat? What am I going to do, Elizabeth? Sure, I'm going to take the equation. I'm going to put in 20 for x. I'm going to take out my calculator real quick here. And I've got 4.9 times 20 minus 37.7. So y will be about 60.3. But my boat isn't just going to cost $60.30. What does this actually stand for? $60,300, right? So a 20-foot boat, sailboat, might cost $60,300, right? So we took the length of the boat, put it in for x, because our x values are length, and we knew that the y would be the cost, because that's exactly what it says in that table up at the top, right? Length is x, cost is y. Bless you. If I actually had this on a graph, like let's say I had the scatter plot all made and I have the trend line, what could I have done to figure out what the cost would be for about a 20-foot boat? Hayden?
Just fix up the point 20 on the graph and see where we would intersect on the line.
Perfect, right? So if you can't visualize what Hayden just said, let's say I wanted to predict how many people might help here on the 10th day. I would go to 10 and I would go up to where this line intersects, and it'd be maybe about 16 people-ish, right? So you would just see where they intersect on the trend line, right? Okay, so we've done part D. Check that off. Now we're going to do part E. Part E says predict the length of a sailboat that costs $147,000. So I'm going to use this same linear equation, but this time, where am I going to substitute and what will I substitute? Where and what? Addie.
For y, you would put in 147. Just 147.
Correct. I'm not going to put in 147,000 because that's not going to be proportional to the 4.9 or the 37.7. I'm just going to put, so I have this same equation, 4.9x minus 37.7, and I'm just going to put 147 here. And then I'm going to solve for x, right? The actual length of the boat. So then I find out that the length could be 38 feet, right? I just rounded up to 38 because I got 37.6938776, right, when I divided here. So that tells me that x could be that value. How could I check my work? What could I do to see if I'm right? What could I do? Grace B?
Plug 38 in for x.
Sure. It absolutely could. And then I would hopefully get really close to 147, right? How are we feeling? Isn't this fun?
This is easier than just the equation part is way easier than.
Yeah. So when you hear someone that's all grown up and has a real person job, and they're like, oh, I'm a financial analyst. This is what they're doing. They're looking at numbers for how much things sell for, and they're trying to help their company make decisions on, right? So some people get really nerded out about it and love it. I think if I wasn't a math teacher, I might try to do this because it's just fun. Like, ooh, what could it be? I don't know. Let's find out. It's like solving little puzzles. Yeah. But, oh, wait, I would work at Starbucks first. So teaching, Starbucks, and then that. Yeah. What?
But you can do Starbucks at night and just not sleep.
I could, but I'm an early morning person, so. Yeah. Hey, did you get your pass from downstairs? You're leaving today at a certain time?
No, my mom didn't have your time to give me a pass because
No, it's okay. There's one downstairs for you. Because you leave at 2:40? Yeah, okay. All right. So now let's talk about the next example. Here we are. We're talking about hours of screen time is what we changed this to because TV is not your only method of watching something on a screen anymore, right? And then your grade point average. So we did A and B, where we found the equation. We found our strong negative correlation for our correlation coefficient. We decided that this stood for 0.08 lower of a GPA for every hour of screen time. Okay, so let's look at part C. Another student watches about 14 hours of television each week. Approximate the student's grade point average. So what am I going to do here with this equation to figure out what their possible grade point average might be? What am I going to do? 14 hours of screen time. Landon?
plug the 14 into the equation.
Sure. X or Y? X, right? Because that's our hours of screen time. Okay, so we have Y equals negative 0.08x plus 3.8. Y equals negative 0.08 times 14 plus 3.8. All right, so this could be their approximate GPA if they're on their screens for 14 hours a week. I think we talked a little bit last week too. Some of us can manage our time, get everything we need to done very efficiently and still have endless hours on your devices, right?
I think it's a week, not a day.
It's a week. Yeah. Hours per week. Yep. Right? Okay. Okay, so this next question. I don't love it. Do you think there is a causal relationship between time spent watching television and grade point average? Meaning, Do you think there's really a strong connection or a weak connection? I think that's what the word casual means, weak.
Weak.
I would say that it's actually pretty strong according to this data, right? But, I mean, you guys might not see that, but there are students that will watch the same amount have the same amount of screen time as you, and they can't balance it. There's no time management there. And so then they're constantly like, well, I didn't have time. Okay, what'd you do all night? Well, I was on, Snapchat and YouTube and all the things, right? But they don't know how to then make it a priority to get my work done, right? I'm trying to figure out a system right now with my second grader because he wants to come home and do like his device, his little Chromebook. And he hasn't, not Snapchat, he hasn't done his reading yet for the day. And his argument is, well, I'm reading while I'm doing this. You know,
True.
that does not count.
True.
He's savvy, that one. Hayden.
My mom was going through a similar thing with my little brother because he just can't get off without starting an argument.
Oh, yeah, it's a battle. It's like I'm negotiating with a terrorist. It's terrible.
Yeah.
Yep. Yep. He won't stop. It's terrible. Okay, so I would say no. It's a. I would say no, it's a strong relationship. I wouldn't say it's casual. I'd say they definitely affect each other, right?
Could I play him for according to the data?
Yeah, according to the data. Yeah, absolutely.
Well, what if it was like a 0.5? Yeah. Would it be like a week then?
So, the thing that makes it strong relationship is like if this correlation coefficient was down in like, is that what you're saying, 0.5? That would be a neutral relationship. A weak one would be like 0.2, right? So, yeah. All right. So now I want you guys, when you have all those filled out, take out the flight activity from Friday.